right, guys, so we're going to look at number 18 before we get started. So let's see here. Yeah. So this is the shape we have here. And they tell us that this is D, this is C, this is B minus 10, and this is B plus 10. Now, we know that the sum of these two angles here is 180. We know that the sum of these two angles is 180, and the sum of these two angles is 180. But we can't solve for any of the three of those sets because we have two different variables. The top ones we have D and C. The two sides we have D and B or C and B. But if we look at the bottom two, those are both in terms of B. And those two angles would add together to be 180. So we can add them together. Well, B plus B is 2B. Negative 10 plus 10. Divide by 2, so B is 90. Now if we plug that in, 90 minus 10 is 80. 90 plus 10 is 100. Opposite angles in a parallelogram are congruent. So angle D is 100. Angle C is 80. So LP, PN is 7, so LP has to be
7. I was like so confused on this because it was like I was thinking like okay 29 was
so that's
here and then I was like
yeah 29 is this angle. Yeah, 7's that length, so that has to be 7. Yeah. Yep. You can go on and grab it.
Thank you.
You're welcome. And you can just pull it right out. Any other questions over the homework? All right, guys, so we're still looking at parallelograms today. Still looking at parallelograms. Now we have the parallelogram opposite side converse and the parallelogram opposite angle converse. And again, we've covered converse before. It's really just the opposite of what the other theorem was. So the parallelogram opposite side converse is really going to say if we have a quadrilateral that the opposite sides are congruent, then it has to be a parallelogram. And the same thing is true at the angles. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. If the opposite angles of a quadrilateral are congruent, then it's a parallelogram. If we have one, we have to have the other. So we have this real-world problem. An amusement park ride has a moving platform. Attached to 4 swinging arms, the platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion. In the diagram, AD and BC represent the 2 swinging arms. DC is parallel to the ground, line L. Explain why the moving platform AB is parallel to the ground. Well, here, the opposite sides are congruent. Here, the opposite sides are congruent. So we can say this figure is a parallelogram, yes? And we have 2 sets of parallel sides. So it means that these sides are parallel and these sides are parallel. Well, DC is parallel to the ground and BC is parallel to AB. Well, we know that AB has to be parallel to the ground. And that's about all we'll say. I mean, we could write that out, but I think it makes sense, yes? All right. In quadrilateral, ABCD, AB is equal to BC, okay? AB equal to BC. They are congruent. And CD is equal to AD. Is ABCD a parallelogram? Right. No. The opposite sides are not congruent. No. Because we need the opposite sides to be congruent for us to be able to say that they are parallel. Questions on this here? Yes. In quadrilateral WXYZ, angle W is 42 degrees. Angle X is 138 degrees. Angle Y is 42 degrees. What is the measure of angle Z?
138.
Is it a parallelogram?
Yes, because they're plus. Well, they're like diagonal. Does that count there?
Yes, because the angles are opposite.
Well, it actually is asking, is it a parallelogram? Do we know?
No.
Well, we do have that two of the angles, W and Y, are 42. Yes?
Yeah. Also,
Do we know
138. Because I thought since it's
if it is 138 degrees, then it would be a parallelogram?
okay, but you have to like add all those three together and then subtract them from 180.
Higher than 180, because it 360, it has four sides, yes? We do know that for sure. So the one way, because it's very tempting to say that Z is 138 degrees because opposite angles are congruent in going that way. But since we don't know anything about the sides, because if it told us that we had the two sets of opposite sides were congruent, then we can immediately say it's 138. Now, if we add 42 and 42 and 138, and since it has four sides, we'll say it is, the sum of the interior angles is 360. So 42 and 42 plus 138 is 222. Forty-two plus 42 plus 138. 222. And if we subtract 222 from both sides, $360 minus 222, we get. So the measure of angle Z is indeed 138 degrees.
Were you doubting me?
So can we say that it is a parallelogram?
Yes.
Because,
Because we are opposite.
yeah, the parallelogram angle converse, or we can say that the alternate angles are, or the opposite angles are congruent. Yep. Both pairs of opposite angles are congruent. Parallelogram, opposite angle, converse. And that's it. For what values of x and y is a quadrilateral ABCD a parallelogram? So for us to be able to say this is a parallelogram, these opposite angles need to be congruent. So we're saying that for y has to equal y plus 87. We're also saying that 2x is equal to 3x minus 32.
Does it matter if we do it backwards? Like 3x minus 32.
They're the same thing. So we can solve for y first. So the first thing we can do is subtract y from both sides, telling us that 3y is equal to 87. Then we can telling us y is 29. Well, 87 is divisible by 3, yes? What's the nicest number that's divisible by 3 after 87? 90? Because 90 divided by 3 is 30, one less than it. Over here. So it's going to be easier or less steps to move the 3x first, so we can subtract 3x from both sides. Which will tell us that negative x is equal to negative 32. Now we can multiply or divide both sides by negative 1, which will tell us x is equal to 32. But it's also the same because if negative x equals negative 32, positive x has to equal positive 32. Possibly. No. For what values of x and y? So if it doesn't ask for the specific angles, we don't have to plug it in, especially if it's asking just for the values. Yeah. Because if you're not sure the numbers look weird, you can plug it back in to see. For x, 32 times 2 is 64. 3 times 32 minus 32 is going to be 64. 87 plus 29, so 6, carry the 1. So 116, 116. And 116 plus 64 is indeed 180. So those are the correct answers. Questions on this here? For what value of x and y is the quadrilateral parallelogram? Well, this one's dealing with sides. So the opposite sides have to be?
Wait, but like there's no other y.
Okay. So we can say these two are congruent, yes? So we have that y is equal to x plus 7, yes? So could we solve this for y or x? Well, no, we have two variables, yes? Because here we have y on one side, x on the other. Let's look at the other sides, though. We have that x plus 9 is equal to 2x minus 1, yes? So what we'll end up doing or having to do is we have to solve the other one, x plus 9 equals 2x minus 1 for x. And once we find the value of x, we can plug it back in and solve the other one for y. Now for this one here, what can we do first? Yeah. Minus x from both sides, which tells us 9 is equal to, and then we would add 1 to both sides. Minus x is equal to 10. Yes, so we'll plug x back in. Notice that we have 10 plus 7, so y is equal to 17. So on problems like this here where it does give you one setup that has x and y, there's a good chance the other one will be in terms of one variable. So you'll have to solve for one and then solve for the other. So here we had to solve for x first, which let us solve for y. It is 2:42. If you want to go on and pack up. Any other questions on this here? So let's look at this one here. Now again, the opposite sides are congruent. So yes. So we do have that y is equal to 2x plus 3. We also have that 24 minus x is equal to x plus 6. So we can't solve the one with y yet because it's in terms of y and x. But we can solve this other one here. So what can we do first? Yeah. We can add x to both sides. And if we add x to both sides, we have that 24 is equal to 2x plus. Then we can subtract 6 from both sides, which will tell us that 18 is equal to 2x.
9.
Yes. Divide both sides by 2, telling us x is equal to 9. Then we just need to plug it back in to solve for y. Yes. And really, once we plug it back in, 2 times 9 plus 3, we can type that whole thing in the calculator and let it do it for us. Any questions on any of this here? Feel good about all this so far?
You like Dr.
Dr. Pepper normally. One of the things is Pepsi actually has higher sugar content than Coke.
It tastes like it was on a stove boiling for 46 million hours and was never done.
So let's look at these last two theorems.
Anyways.
If one pair of opposite sides of a quadrilateral are congruent and parallel, then it is a quadrilateral. Then it is a parallelogram. So if we have one set of sides that are congruent and parallel, then it's going to be a parallelogram. And the other one, if the diagonals bisect each other, then it's going to be a parallelogram. So if the diagonals bisect each other, it's a parallelogram. If we have one pair of congruent and parallel sides, then it is a parallelogram as well. The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to TU. SV is congruent to TU.
Opposite sides parallel.
Yes.
ST are both parallel and the same. Look at that word.
Yes.
Wait.
So
Bottom is slanted, top is
Yeah,
not
that's-
slanted.
it looks like it's not.
Everything is slanted.
Yes. So because these two sides are congruent and parallel, it means it is a parallelogram.
Yeah.
And because it's a parallelogram, the opposite sides are congruent. Yeah. So ST, SV, and TU are congruent.
Well, it probably isn't really congruent in real life. It's probably just how they have it written.
Now, one of the other things is our brain, the way that the door looks, the top and bottom don't look like they are, but it is proportional. It's just hard to sometimes see it.
It's probably something stupid that looks like it fell into. That's what happened. Like this round.
I think probably what they've done over the years is redid the door or fixed the door so that it fit the frame as it slowly moved.
Like the bottom, top, that way.
How does the building just slowly slant?
As it rests, sometimes the flooring or the concrete, the base will change. That's the reason the Leaning Tower Pisa leans, because it wasn't built that way, but the ground is slowly sinking on one side.
Oh, if you look, now you're reminding me of Dark Tower. They were talking about the Leaning Tower. If you look at the
other questions on this so far? State the theorem you can use to say that these quadrilaterals are parallelograms. So for number 3, it is our opposite sides parallel and congruent theorem. Because our opposite sides parallel and congruent theorem tells us that number 3 is congruent, because we have a pair of congruent sides, or have a pair of sides that are congruent and parallel. So that's just the theorem. Number 4 would be the parallel opposite side
I didn't think you were like legit writing down the answer. I was like, what?
opposite sides converse. Because the parallelogram opposite side converse theorem states if the opposite sides in a quadrilateral are congruent, then it has to be a parallelogram.
Converse Venus actually means
Mhm.
the naming of
It's if you remember back to chapter, I think it was 3, the converse, because we had the conditional statement. The converse was the flip. So the parallelogram opposite side theorem stated if a quadrilateral is a parallelogram, then the opposite sides are congruent. So the converse, if the opposite sides in a quadrilateral are congruent, then it's a parallelogram. So it's just the flip of the original theorem. And the last one is our parallel opposite, not sides, but angles converse. Any questions on this here? Almost. For what value of x is quadrilateral CDEF a parallelogram? Well, if it's a parallelogram, the diagonals bisect each other. Well, they've already told us that the diagonal from C to E is bisected into 2 congruent segments, but we also need that FN and ND are congruent. So if they are congruent, it means that 5x minus 8 is going to be equal to 3x. So we can subtract 5x from both sides, which will tell us that negative 8 is equal to negative 2x. Then what would we do next? By negative 2. Because negative 2x divided by negative 2 is going to be x. Negative 8 divided by negative 2 is, so the value of x that we need is 4. And that's it. Questions on this here? Do we feel comfortable with this here? Because the other 2 examples that we have are the exact same thing. Nothing any different. It's just set these 2 equations equal to each other and solve for the value of x. If we feel comfortable with this, so what we've learned so far with all these ways to prove a quadrilateral is a parallelogram are these here. The one is show that both pairs of opposite sides are parallel. That's the easiest way to do this, because if by definition a parallelogram is a 4-sided figure with 2 sets of parallel lines. Now, if we could show that both pairs of opposite sides are congruent, then it has to be a parallelogram. Or if we have both pairs of opposite angles are congruent, then it's going to be a parallelogram. We also have that if one pair of sides are congruent and parallel, then it has to be a parallelogram. And the last one, we show that the diagonals bisect each other for it to be a parallelogram. Now the fourth one is the one that kind of makes, it does make sense, but you have to think about it a little bit. Because if these two sides are parallel, that means they're not getting any closer or farther away from each other, yes? Because if they are getting closer, it means they're going to intersect. If one side's getting farther away, the other side has to be getting closer. Now the other two sides, so they're not getting closer or farther away, but these lengths are the exact same, yes? So that means the two endpoints of the lines, are they getting any closer to each other? No. So the only way that works is if the other two sides are parallel. That's why this works. But that's all we're doing today. So 3 through 16, all. So 14. So 14 problems, 3 through 16.